Forget everything you know about n8n because most tutorials are teaching it all wrong. The biggest problem with learning n8n is focusing on specific nodes instead of the core skills you need. And after teaching over 500 students how to master it, I've seen exactly what makes the difference between struggling and success, and ultimately a much faster way to learn it. So today I'm breaking down just 3 simple concepts that will make n8n stupidly easy. Master these and everything else will fall into place. So by the end of the video, you'll know how to handle any data that comes your way, connect to literally any system with simple API calls, as well as transforming data exactly how you want with basic code. Understanding these concepts might just be the difference between dropping n8n and mastering it. So let's break down the 3 concepts, starting with data manipulation. So you're going to go straight to n8n.io/workflows, which is where n8n publish all of their free and paid templates. And you can see they've got 3,043 workflow templates, and this is increasing by the day. And I found some really great beginner resources, all by one person, which I'm going to show you in a second. So first we'll go through the Learn JSON Basics. So all you need to do is type in Learn JSON Basics here, and it's going to come up with one result. And Lucas Peyron, I hope I'm saying that name correctly, has created a series of beginner workflows. He offers coaching, etc. as well. And we're going to run through a few of those and master some of these concepts today. Let's start with the Learn JSON Basics. So if you click on the workflow itself, it's going to open it up in a separate window. You can effectively see what the workflow looks like, read some information about how it works, but a quick cheat sheet on how to grab this, you can actually just copy and paste. Once you click Explore, copy and paste directly from here, open up your own workflow environment, and all you're going to do is just copy and paste that in, click on there, and it's going to paste that directly in here. So the concepts that I found most difficult when I was starting out to master were all around what's closest to actual coding. So the heart of n8n is the fact that it's a drag and drop software with very low code/no code, but some of the terminology around JSONs and the code and JavaScript and things like that, actually the principles come from coding. And if you understand those principles, you can effectively tackle most issues inside n8n. And the heart of that starts with actually JSON, which stands for JavaScript Object Notation. And this tutorial, the first tutorial, walks through exactly those different points. So we will walk through an example of the tutorial and explain every bit by bit. So it starts with what is JSON, and this workflow will teach you the basics of JSON, the language that apps and n8n nodes, that's really important, use to exchange information. We use JSON because it's very internet friendly, but it's also a really compact way to store data. So imagine a contact card. We've got John Doe, age 30. He has children and he's got a phone number. So we've got different things in here. We've got a name, we've got a number, we've got a Boolean for a yes or no. So actually a Boolean is true or false, and we'll cover that in a moment. And we've also got a number which is in this construct, which has the square brackets and multiple strings inside that, because it's actually a list here of 2 phone numbers. So JSON is just a way of writing this down so the computer can understand it perfectly, but also understand the data types. So we're going to follow the instructions here and execute the workflow. And then what we'll do is we'll go through each part of the JSON data so that you can see exactly how that is. So when we start the tutorial, we've got a blank JSON data in here, and inside n8n we've got the schema, the table, and the JSON, and we'll go through each of those. But if we move into the first note here, we've got the keys and values. So it's important to understand that everything in JSON language is built around this key and value pair. So we effectively have a key, which is the name of the data itself, and it's always in double quotes, and then a value, which isn't always in double quotes, and we'll show you what formats aren't in double quotes in a minute. We've got the key and value inside here. So if we switch to JSON data on the output, you can effectively see that the JSON starts with these curly braces. And if I just zoom in a little bit, in the fields that we've set in this edit fields node, we've got a key with a value. And if we remove those, we've got the name and the value. So the name is just effectively the name of whatever data field we're labeling it. And then the value is the actual value. So this is just a key value pair. And you can see that it appears like that in the data type. And then if we switch the table, it effectively represents columns and rows within that table. So we've also got a second key value pair, which is another key and another value. And you can see that that is distinguished by the comma after the first key value pair. We've then got another key value pair there. And that just distinguishes their completely different points of data, but within the same object. So the object is represented by this JSON object, which is the curly braces. And you can see this is a really easy example to understand because all we've got to do is click execute workflow and we can work through each of these. So let's talk about the data types. So the different data types that you're mainly going to deal with, firstly, are strings. So string is simply text. And text is always enclosed in double quotes. So if we have a look inside the node here, we've got an example, which is the key is our JSON underscore example underscore string. And this doesn't need to be underscore underscore. It could be JSON example string, exactly like that. And then all we've put is a sentence in here. This is a simple string in JSON. It's always enclosed in double quotes. And actually you can see that that is a key value pair with the key there, and the value is a string, which is just text in this case. And all we're doing by putting it in double quotation marks is telling the computer that's receiving it that it is a string and it's therefore text. So then we move on to data type of number. So now that you understand always everything in double quotation marks is a string, everything outside of that is not a string. So it can be a whole number like 10 or a decimal like a float like 12.5. And if you want to write a number in there, say our age, we'd effectively write age of 30 with no double quotation marks, and then that would appear correct. Whereas, like we said, strings always have double quotation marks. So you can see in the examples here, we've got the JSON example integer of 10, and we've given it the data type in here. So n8n makes it really simple for us to actually just give it that data type. If I put string inside here and we reran this, you'd see it appear in double quotation marks. So let's go back to number. Let's run it as number. And n8n has done all the handling for us, but it's important that you understand that you can manipulate numbers in a certain way, like adding them and subtracting. You can't do the same with strings. So if you pass it through as the wrong data type, i.e. a string, it's going to be hard to manipulate it later on. And you can see in our JSON format, again, we've got the numbers here and they've appeared in green. So they actually visually appear different to the strings. And if I run it as a string, it will appear in blue. And we can see again in the table, we've got the numbers that appear there. And if we run it through as a string again, you'll see that that is slightly different when it runs through. In fact, in the table view, it appears exactly the same because the table view doesn't show us the data type. But in the schema view, we can see that actually the schema effectively shows the data types for one example. And you can see this A represents that it's a string now, whereas the number represents this as a number. And in JSON, we can actually see the distinguishment between number and string now with the quotation marks. So the next data type that's really crucial you'll see so often is a true or false, or this is what's called a Boolean. And this is always written as lowercase, so true or false. And you can think of it like a light switch. So it's either on, which is true, or off. And it's super useful for actually saying, if this happens, then we take this action. If this does not happen, or if it's false, then we take another action. So this is how our if blocks work. We effectively say, if this condition is true, then or this condition is equal to this, then we take a certain action, which is our true branch and our false branch there. But actually we can do this inside the data types themselves. Data types can be Booleans or true and false, and you see this expressed as a tick box inside there. And if we run this, what we're going to see is that it appears as a different data type, which is a green true, whereas if again we ran this as a string, we would see the quotation marks around this. True or false is as simple as that, but we use it later on to actually decide how to take actions on certain things. And although this initial example has children, yes, is not a true or false, we could effectively turn that into a true or false. Yes, no, instead of strings, could be true or false because it's just got two conditions. Is it true? Yes. Is it false? No. And then something that you'll see quite a lot when you've got large data sets but missing items is actually there's a data type specifically for null, and it's always written lowercase and without quotes. So it's different from 0 or blank, which is actually an empty string. Null is the intentional absence of a value. So when something is completely missing, we can effectively give it that null data type. And when this comes through, you'll often be working with a large data set and you will see a red null come through or an empty object here. And this is different from undefined, which we will cover later. But effectively here, we're seeing that it's passed through as an empty object or intentionally null. So we can actually assign that null data type in there. Next, we have an array. So an array is effectively a list. And we saw that the phone number was a list of 2 mobile numbers. And an array always starts with these square brackets and ends with the square brackets. And items are separated by commas, and they look like strings inside usually, but actually they can be anything. They can be numbers, they can be booleans, but an array is effectively multiple data types in one single construct. And that's because actually in this JSON example array, if I run this, we're assigning multiple values to one single key. So if we remember that we have a key up here, which is our what n8n calls a name, and we're assigning multiple values to that. So what we're doing is assigning a list, we're putting them in these square brackets and giving it this array format. You'll often be dealing with array when you've got complex data structures. And inside the JSON object, which is denoted by the curly braces, you can see that we've got our key here, JSON example array, and then the array denoted by multiple objects of different data types, a number, a boolean, a null, and a string inside that object. And if you remember, we have the data type of multiple phone numbers earlier on. This would be denoted by 2 strings inside an array there. So we'll now show you an object within an object. So we've come full circle here, but this is where effectively you've got a nested data structure. So if we go back to our example inside here, we effectively had an array within an object. You can also have an object within an object, so a JSON object. So if we go into the example, it makes it much clearer in how it's visually displayed. We have our key and our value pairs, like array and 1, 2, 3. But then we can also have a sub-object, which is denoted by the curly braces, and sub-key and sub-value here, which is sub-key and find me. And n8n breaks this down really simply for us by most of the time you'll be receiving in data from your software system, so you won't actually writing these out manually, but n8n's able to tell by the way that it's ingesting the data what data types they are, and that determines how you actually manipulate the data, which is the really important thing you understand here. So in this schema view, we're able to see the nested data types. So everything's denoted by a drop down. So the larger JSON object has an array which has multiple objects in, or not objects, sorry, multiple key value pairs in. And then we have the sub object with the sub key down there. And then anything that's on its own is just listed as a key value pair, which is a boolean and false, for example. And in the JSON, you can see that that's denoted by the curly braces as an object in there. So now we're going to show you how to actually use that data dynamically. So we're going to use that object as an example, and we're going to go into the next one, which is using JSON expressions. And actually what we can do is just run a few examples through of how we would use this data dynamically inside n8n. And the first example we're going to do is basically retrieve data from a previous node. So on the left-hand side, we can see all of our inputs. On the right-hand side, our outputs. And I've got specific tutorials that cover exactly how to manipulate JSON data that go into way more detail than this. They're available in the school community description, but we'll cover the basics now, which is actually if we wanted to retrieve a number from a previous step, we effectively can pull that data dynamically. So we want to get rid of all this and make sure that we're on the expression inside here, or a shortcut to do that is just to hit equals, and you see it will put the equals box here. And all we're going to do is try and pull the equals from a previous object. So on the schema view, we can see all the previous nodes that we've looked through: object, array, boolean, and number. If we open up the number, which is actually this set node all the way back here, we can pull the data from that dynamically. So what we're going to do is just drag and drop that directly over here. So we'll go down to the number node, and all we're going to do is just grab the number or grab the float from there and actually turn that into a string on the output. Or actually, let's just keep it as a number. And let's just execute that step and it will appear as a number again. So we've pulled that number from a previous step. But what you can see, which is the important part, is happening is we are digging into the object. So we are effectively denoting by this notation that we're going to retrieve from the number node, what we call number. And every time we retrieve something from there, we're effectively saying pull the item. So we're going to put .item, .json, and then inside that, we're just going to name the actual key that we want to pull. So in this example, it's JSON example flow. So if we were to write this again for the Boolean, we would effectively put, and if we open up those curly braces, it's always, the dynamic data is always written with double curly braces. If we go down to the bottom, we can effectively start to see the different nodes, earlier nodes, you see up here, earlier nodes, and where we're pulling the data from. So we will go to the Boolean, we will hit tab to make sure that goes in. And then if we hit dot, it will suggest our path. So .item, .json, and now we've accessed the object, which is this Boolean nodes object. If we hit dot again, we're effectively going into that object and pulling this example. So JSON example Boolean, and you'll see that appears as true. If we get rid of the number there, you'll see this appears as true there, and that's the exact value pulled. Now to dig deeper into an object, like a sub-object, we just need to again use the full stop notation. So let's say we're pulling the sub-object, let's just call this sub-object. We've got the equals again, let's call it a string. And what we're effectively going to do is open up those curly braces again. We're going to do exactly the same, which is call on the previous node, which was called object. And we're going to dig into it, .item, .json, always .item, .json, unless you're accessing the last object. And then inside that, we've got JSON example object, which is our master object here. So we know we're digging into that master object. And then inside that, we can go into our sub object, which we can see, and n8n breaks it down as a sub object. And then inside that, we can say sub key. And there we go. We've got the find me down there, which is our second example down here. The only other notation that you need to know is when you're trying to access values in an array. So values inside an array, because they're lists, are accessed in slightly different ways. So again, we'll open up that notation. We will go down to the earlier nodes and do the object, .item, .json example object. So now we're in this master object, and now we're going to go into the array. So inside the array, we have a choice here. If we hit dot, you'll see there are no suggested values. And that's because inside the array, there are no key value pairs. If we go back to the JSON and how the array is displayed, there's no keys and values like this sub-object. It's now just a list of values. So what we can do is effectively pull the whole array, which will appear as an array 1, 2, 3. Or if we wanted to access a certain item, like number 3, then we can give it an index value and use the square bracket notation. And you see if I open up the square brackets, it'll suggest to me 0, 1, or 2. And that's because indexes start at 0. Index 0 will pull our 1 value. Index 1 will pull our 2 value. Index 2 will pull our 3 value. It's a little bit confusing at first, but just know that it always starts at 0. So we hit 0 and it's returned our first or 0th value, which is 1. So that wraps up JSON expressions, JSON types, JSON manipulation. Like I said, if you want to dig into this in more detail, I've got more in the school community below, but this is a really fundamental concept to understand when you start working inside n8n. Next is such a critical concept, which is accessing data that's not inside n8n. So n8n has maybe 1,000 inbuilt nodes, maybe less. And actually, when we're working with business systems, we're always going to need to access data outside of n8n. So today we're going to cover API, HTTP requests, how to use them, and common errors. And to demonstrate this example, I'm going to run through some key concepts first, and then I'm going to go to a template, which is completely free, that's going to teach us all about API fundamentals, and we can see it step by step. So first and foremost, what even are HTTP requests or API calls? Well, when we can't access the data that we want inside inbuilt nodes inside n8n, we effectively need to reach out to external systems to get that data. So say you're working with an accounting software like FreeAgent that doesn't have an n8n inbuilt node. What we can do, for example, is go FreeAgent. I'm sure there's one for QuickBooks in here, QuickBooks on mine, but for example, FreeAgent, there is one. So if we needed to access that service, we'd effectively want to grab our data from there, and we need to effectively manipulate or call that system in order to retrieve our data. And Free Agent will have a set of predefined, what they're called endpoints, that we can reach out to grab data in a structured way from them. So it's effectively like scraping a website where we pull data, except for the fact that Free Agent has defined this is the way in which we will pass you data back. And you are able to do that, and we'll give you an API key to prove it's you doing it. So if we have an example n8n workflow here, we have a trigger. We then want to grab the data from Free Agent, for example, or another site. We're going to process the data and then output. So the way in which we do the HTTP request or API is use this HTTP request node, which you might be familiar with. And all that's doing is effectively saying, give me that data, or I'm going to send data to you. And what you're going to do is provide me with a response, whether that response be the data I'm requesting, or whether that response be to confirm that the action I wanted it to take has happened. So there's a few methods that we can use inside n8n or any API request. The first is a GET request. And by the way, these are all very, very straightforward once you understand the concepts. The first is a GET request, which as it sounds is retrieving data from a system. So in our Free Agent example, we say, what were my transactions in the last month? If we are posting data, we're actually creating new data in the system. So we might be sending an invoice or text or something to our Free Agent software. If we are updating data, we'd use a method called put and patch. And you can see these are all capitalized and they will always be capitalized. And then finally, we can remove data. So as it sounds, it's delete. And here's some examples of how we would do that. So we would send a GET request, it's called, to actually retrieve data. So we might get the users list from our software. We might post or send a new user data, and that they would then be registered and set up in the system. And we need to do that in a certain format. We might update a user with certain details, or we might delete a user. But what we're going to receive back from the API pool is actually a return message. So every time we contact an API, the provider is going to set up a return message, which tells us, was our mission successful or was it failure? So we have these different error codes that often come up. The ones starting in 2s are successful. You don't really need to worry about the the numbers after the 2. If it's 2, we know it's a success. If it's 4, we effectively couldn't do it, and the error is on our side, so the client side. So for example, we've got 404 not found. So when you try and access a website and it comes up with 404 not found, we can have the same if we try to contact an endpoint or a URL that doesn't exist. We effectively will get this response back to tell us it had failed. And then there's all sorts of other errors, but they start with 4 and it shows us that actually we've done something wrong. Whereas 5 errors, or errors that start in 5, are server errors. So if we try to access a service, it comes back with an error with 5, then it's often on their side that the issue is happening. So we'll jump back to this diagram here, which is the n8n API endpoints integration. We talked a little bit about accessing certain endpoints. So endpoints are just URLs. So if, for example, we want to retrieve the users, then we will have a base URL followed by an endpoint. So the base URL might be freeagent.com or whatever their website is, but the endpoint that we're trying to contact is the user's endpoint, which is /API /v1 /users. And we'll cover that in the n8n example. But again, we'll have multiple endpoints for different information that we want to get, post, delete, update. And then the only additional thing you need to know are around headers. So often when we're trying to access data, the system needs to understand that the request is coming from us in order to stay secure. So we need to pass headers in the form of authorization. So what we're saying here is actually, here's my API key to prove who I am. And it's like showing your ID card effectively to give you permission to access that content. We then sometimes send additional headers, although n8n actually does this automatically for us. So we don't always need to do this, which is I'm sending JSON data, which is the content type header. And then please send this type of data back, which will be JSON. And this will always by default in n8n be JSON data being sent and JSON data being received. So we often don't even need to define these. You just need to worry about how to set up your authorization. So let's jump into a really clear example now. And the way you can do that is go to the n8n template library, and you're just going to go learn API fundamentals. And this again is a template set up by Lucas Payrin, and he's got some really great beginners templates, and we're going to run through that template. It's going to appear as a page like this, which gives you more info, and all we're going to do is just copy that whole thing and paste that into a brand new workflow inside n8n, and we're just going to make sure it's activated. Right now mine's deactivated, and we're going to run through the fundamental concepts of actually sending a request using a really basic example and the different concept we just covered, but in practice, so that you can implement it with absolutely any API. And if you're looking for more resources around handling more complex cases like file uploads, authorization, anything that's slightly more complex than this use case, we cover that in the school community linked in the description as well. So it starts off the tutorial with what is an API, and actually we're going to go over a very clear example, and we'll show you both HTTP requests and webhooks as well, and talk about the difference between them. But actually you'll see how to use both inside n8n. And once you understand this, it's really going to clear up how to access data outside of n8n. So think of an API, like we've covered the fundamentals already, like you are making a request. So you are the client and you're using this HTTP request node, which you can get by just typing HTTP in the tab here. And effectively we want something. We either want to get data, like we talked about, we want to send data, delete data, or update data. And if we think about this like we are ordering at a restaurant, the kitchen is the server. So the kitchen is our free agent example, which is our accounting software that's going to send us back information. So we'll treat it like us ordering from a kitchen and the kitchen sending something back. And then the API is effectively the way we communicate that. So in a restaurant, that would be the waiter, and also it would be through a menu. We can't just order something off menu because we'd get rejected. So we have to order on menu. And the on menu in this case is actually our API documentation. So whenever we connect to a service like Free Agent, we would go to their API documentation, and we're not actually going to use Free Agent as an example, but you would see the API docs and it would tell you what's on the menu. And you can see that this is a pretty comprehensive menu here. But actually we could effectively find the API docs where it would tell us what URL to reach out to, so what endpoint, but also what information to send in order to get the right information back. So we're going to cover that with examples here. And once you drag and drop this workflow into your environment, you just need to make sure that it's an active workflow so that the webhooks are going to work. And what we're going to do is just get it to execute from the start tutorial node. And that should successfully execute all of these nodes in here. And we'll go through all the different requests and what exactly they mean. But one thing you have to define first is this base URL. So when you download the template initially, it will have a dynamic bit of data in there. This dynamic bit of data might not work for you. It didn't work for me, so I've updated it. So instead of the dynamic bit of data, what I've done is just gone to the first webhook over here, gone to the production URL here. I've copied that, and you're going to need to do the same probably. And you're going to go into this webhook here, open this up. Let me just check that I have done the correct thing. Yeah, we're going to copy and paste that in, but we're just going to get rid of menu on the end. So you're going to end up with your instance URL, your server URL, webhook, tutorial API. And what we're doing by doing that is just defining that this is the service we're going to send it to. So we're actually, in some weird way, sending it to our own server so that it can send us information back. And the way we're doing that is we are sending information to a HTTP request to our own server up here. And even if you've got a different domain, like I've got n8n.scrapes.ai, it's still going to contact your actual end server URL unless you've totally changed that, because the webhook, we're basically trying to get the webhook to send this information back. So just quickly, the differences on API requests versus webhook. You can think of an API or HTTP request as us reaching out for information. You can think of the webhook as information being pushed back to us. So say, for example, you took payments through Stripe, you could set up a webhook where every time a payment comes in, immediately Stripe sends you the information, and that would be the webhook, this little node here, pushing information back to you. So when we set up a webhook trigger inside n8n, again, we just open up and we say webhook. We're effectively saying that, okay, Stripe push to this production URL. So we put that in Stripe somewhere. And actually, Stripe would send information to this webhook. So if we had our workflows active, our webhook would receive that data. We could take information with it. Whereas this is actually a push request where we're sending data. So we've got send data, HTTP/API request, receive data, which is webhook. And we've got to set the webhook up. But here we're acting out actually both sides because we're sending data to our own instance. And therefore, by default, we're receiving data. So we're sending data to this webhook effectively. So we can actually see what that webhook would respond. So in the first example, let's just talk about the basics. We've talked about the GET request and the URL. So inside this HTTP request, we've got no authentication because actually we've not put this behind any barriers, but normally we'd need to, with a service, set up an authentication type, and that will all be in the API docs. It's usually a generic credential type, header auth. And if we open up this, you can see I've got loads of header auths in here. Create new credential. We don't need to do this for this example, but we'd say, okay, let's use the free agent example. We'll call it free agent header auth. And usually 99% of the time, the name would be authorization, and the value, if we just hit expression here, would be the word bearer with a capital B, underscore, and it would be your API key here. And you'd grab the API key from the service. It's not always going to be that, but 99% of the time, it honestly will be that. And you change that to fixed so that it doesn't show your value, and then you'd save that in there, but I'm not going to save that now. And it would say in the authorization section of the API documentation exactly what that would be. So we're going to go back to the example here. And what we're doing is effectively, we are saying, if I just remove this authentication type, we're sending no parameters inside here. So this is the simplest type of request. We are using the get method, and we don't need to worry about all of these right now. But what we're saying is, from this endpoint, send me information. So it's just grabbing the endpoint, which is, as you can see, our base URL from the previous node. So we're saying pull information from here. And this is effectively saying that this is the endpoint. So we've got our base URL here, and then the endpoint is our tutorial/API/menu. So what it's going to do is it's going to respond with this information. So we've told it to respond with pizza and price of 12. So our menu here. So once we say get and we contact the correct endpoint, which is our tutorial/API/menu, it's going to push back this menu here. So when we run this, although you don't see this running, it effectively has run. It's run in a production environment, and it's sent us back that information. So if we go into here, we've received back item and 12. And then if we go to our production executions up here, we should see that this has actually been executed. So you can see that all of our executions of these HTTP requests, but actually you can see that 1, 2, 3, 4, 5, which are our 5 branches, have all executed independently because the workflow is active, and we've sent requests to these different webhooks. So if I zoom in now, you can see that immediately afterwards, 18 milliseconds after the first execution, that this received the data we sent, which was just a GET request to the correct path. And you can see it's got no parameters, nothing in it, and it's just saying it's come from this host, which is our server, effectively. And then it's just responded with that information. So it's sent pizza and 12. And then if we go back into our what we've actually received, it will be pizza and 12. So by default, we've executed a GET request to pull information, and this has just acted as a dummy, sending back two pieces of information, the price and the item on the menu, which is pizza and 12. Now let's talk about when we actually want to customize the parameters and customize specific things, and that might have conditions in the webhook that's responded. So let's say, again, no authentication here, but we want to place an order. So we're going to contact the order endpoint, and what we're doing is, again, it's just a simple GET request. So we're getting information, and we're basically saying, okay, I want to pass in that information a query, which is, can I have extra cheese, please? And it's going to respond back to us a success message of, okay, you've ordered pizza with extra cheese. So we can see in the webhook that's going to send back that effectively it's got this condition here. If extra cheese in the query is true, then respond with pizza with extra cheese, which is the condition we got. And then actually, if not, then it's going to respond with plain. So if we put extra cheese as false, you'll see that the webhook is going to send data back as, whoops, plain pizza. Let's just execute that again. Plain pizza is returned. So we've contacted the service, which in this case is our own webhook, and that has sent information back to us. Quite a clever way of testing out different API use cases, but usually you'd be contacting an external system. Now let's talk about posting data or sending new data. So quite often you'll be updating data. So say, for example, in our free agent accounting software, we might be sending an invoice in order to map it to a certain example. So we're going to use the post method in here. And then inside the body, we're going to tick send body. We're actually going to send JSON data. So we're going to send the customer review. So we're going to send it to the review endpoint. And you'll see that this will have a path of review at the end. And effectively what we're doing is actually just sending a comment there. So we are posting that information, and that information will be received by the server. So we might post a file to free agent, and that would receive the file and confirm back to us that it's received the file. So if we run this, again, we'll just execute from the start, we're effectively going to see that the status come back as like a 202 or a 202 equivalent. From the actual service, it would probably usually give us a status like 2XX, and then it's saying this is the data that's been updated. So the service itself defines the structure in the return. So right here, we as acting as the service, we're going to return the comment. So we're going to return the data that they've uploaded, which is quite common, and then the status, which is review received or 202 review received or whatever. So let's say 200 review received, let's save, let's rerun, and this will now come up as 200 review received. So they'll have a structure that they'll conventionally send back, and it will tell you that structure in the API docs. Okay, we're getting on to the more complex concepts now, which is all about headers and auth. And yeah, think about it like showing your identity card to prove that you are who you say you are. You don't want people accessing your accounting information without proving that you are them. So for example here, what we've got is there's a secret dish on the menu, and we want to get information about that secret dish, but it's actually behind a password. And what we would do is send a header, but the best way to do this is actually to add it in the authentication type. Like I showed you just now, we take credential type, add it as a header. This would work in exactly the same, but let's assume that in the API documentation, it's called an x-API-key, and this will always be in the API docs. And then let's say our API key, as an example, is your API key, for example. And if we get that right, then the service is going to say, okay, this person is allowed to access the data and give us that data back. If we get it wrong, then it will not send us that data back. So we've got this or if authorized chain here to show you this example. So inside the webhook, you can see that we've got the endpoint, which is secret dish, and then we're effectively simulating whether it's authorized or not by saying, actually, if you have the right key, which is actually if the API key on the request is equal to this, and the service would be doing this in the back end in using much more complex methods, but this just simulates if the key received is equal to the key on the system that's registered to that user, then we're effectively going to respond with that. And if not, we're going to respond with an error. So if it's an error, it says you are not authorized. So let's test it out with an error. And let's just say, actually, we got the API key wrong, and we execute that step. Then the dish is going to come, or not come back, and it's going to send us actually an error, you are not authorized, which throws us back to these error message in here, which is effectively like a 400 client error, which is we've got something wrong, and it's actually no permission or unauthorized here. And then finally, we're going to cover some important concepts around additional options. So often when we're sending these API requests, we need to make sure that we are, one, respecting rate limits of the service they're providing with us the data, and two, actually respecting our own software and infrastructure and making sure that these don't break. So we're going to simulate effectively an endpoint, which is actually, we've got this slow service. So actually the webhook here you see has a 3-second delay. So this simulates there's loads of requests going into a given service, and actually it's not able to handle the requests, and therefore it's slow on giving us information. But that information is really important for us to receive right that second, and therefore this one's actually designed to fail, because in our options or parameters down here, we've got this timeout, which is after 2000 milliseconds or 2 seconds, just don't receive any data, stop working. We're no longer interested, because the data is really important to receive that second for some reason. So if we start the tutorial again, you're effectively going to see that this is going to return with error, timeout exceeded of 2 seconds in there, and this is just saying that our fetch request for the information failed. Whereas if we change this to 1.5 seconds, you'll see that this probably succeeds now and pulls the information back, which is finally your food is here. So it's just showing the importance of different options down here. We have things like batching, so there will be rate limits on most API requests. You can't just continuously send data and bombard it, so it will reject you if you don't respect those rate limits. So let's say 50 items per second it allows, or any other quantity there. And then there's a few other options we can use, but rate limits and timeouts are the ones we're going to use most frequently. So that is it on HTTP requests and webhooks and how to use them inside n8n. If you need more information around those, then check out the school community in the description below. We've got way more in-depth resources around using these in practice. Now, this is the closest you're going to get to actually coding, but will unleash a lot of additional flexibility once you understand the code node directly inside n8n. And this just allows us to actually extend the functionality of n8n to do things that JavaScript code would be able to do. So things we can't do conventionally inside n8n, we're able to actually extend that and use the code node to do that. So we're going to show you a really cool demonstration of a free template that shows you how to do that. So go to n8n.io/workflows, and we're just going to type in learn code node, and we've got another example from Lucas Peyrin here, and we're going to go into that example. We're going to click to explore, and we're going to copy and paste. Just copy that, copy it, go to a new workflow, and you're going to paste that in, and it's going to look a little like this, and it's designed to just execute workflow, and that will run through, and you will be able to see exactly the different elements we're going to run through now. But lots of other platforms like Make and Zapier don't allow this additional functionality, so this makes n8n really powerful. And once you understand this, you can actually pretty much do 99% of things inside n8n. So we're going to start with some sample data here, which is effectively a list of users, and you can see this is a set of JavaScript objects with first name, last name, and birth date. So we've got 4 different users here, and what we're going to do is just see that sample data on the right hand side. It's an array of users all in sub-objects with key value pairs, and we're going to use the split out node to split out the users object. We just drag that across there, and that's going to show us now effectively, if we were to put it into a table of it splits out the users compared to a table here which has one great big row with all the different users in this array. You can see it's been split out nicely, and that means we can process those rows individually. So what we're going to do now is take those users and actually manipulate them with the code node. So say we have a bunch of users and we want to perform some actions on those users. What we're going to do is show you how to use the code node to actually do that. And the first thing we're going to cover is like how to process each of those individual users using that code node. So if we go into the code node, and actually if I set up a new code node, you'll see exactly how this starts. So it says you can run once for all items. So every single item, every single name user that comes through, we're going to run that once. We can choose JavaScript or Python, but to stick with the JSON object notation, I would recommend, if you're going to start by learning the expressions of one, just go with JavaScript, because the rest of n8n is manipulated using JavaScript object notation or JSON. So there's always an example in this field, which is loop over input items and add a new field called myField to the JSON of each one. So if we actually run this, we will see that for each of these users, it's going to basically say for each item in our input, which is take all of our values from our input, return this object, which is effectively return everything you've been given, plus a new field called myNewField equal to 1. So if we execute that step, you will see that now we have a my new field equal to 1, and we look at the JSON and it's effectively added a new key value pair. So we're going to do the same, but for different use cases. So let me just delete that there. What we're effectively doing here is grabbing the input data. So we're saying, okay, each user, and we just called it user for ease of us seeing this, each user is equal to the input item, as we saw, $input, and that's just how we denote it, .item.json. So each user is effectively this collection of details. So this would be grabbing effectively this object here, right? Because that's the JSON. It's the input item JSON. Each full name is $input.item.json first name plus last name. But the way we can write that is because we've already denoted that a user is this object here, first name, last name, birthday. We can effectively say inside this, grab the first name. So we just use the dot notation again, and we're effectively just putting it in these backwards apostrophes here to pass in dynamic data. So first name and last name, just to denote that it's dynamic data, because if we, for example, use these exclamation marks, this will come out as user first name, user last name, and it will understand it as a string. There we go, user first name, user last name. But actually, we tell it that it's going to receive dynamic data by using this notation here, and full name, you can see, combines the first name and the last name. We just do, again, a few different manipulations. So birth date, we're actually just going to effectively pull the birth date, but we're turning that into a date type. So we're saying it's a new date. So this is just data type manipulation. And here we've got a few manipulations to work out what their actual age is. So again, it's just like, if you don't look too much into the details, it's saying, okay, let's define this constant, which is a birth date, which is this value, which is a date value. We're saying that should be treated like a date value, not a string, like it is in the input. And we're saying, okay, let's take the date of now, and let's take the date of the birth date, and let's subtract the difference. And what we're going to get there is the age as a number. And then finally, all we're doing is saying return that new data, but keep the original fields as well. So the way we can do that is at the end of each of these, there's always going to be some sort of return statement. So what we're saying is return, and then ... user says just keep all the original data, which we defined up here as input.item.json. That's why we called it user. And then also return the full name and the age. So if we were to remove this user here and run it again, it would just return the full name and the age. But we want to return everything inside there. So we use $, and even though it's got a thing that suggests it's wrong there, it's actually correct. It's called the spread operator. If you've understood this so far, you will know 80% of it. And you don't always have to write these completely from scratch. You just need to understand how to read them, because actually you can use things like Perplexity and Claude, paste in the example code node and say, I want to do this action on this data. Can you write a code node for me? But once you understand how to read it, you can do that. Now it's getting more advanced, which is like sometimes you might want to fetch external data. And I didn't even know you could do this until I started doing this tutorial. So this is awesome. But effectively what we're saying is actually we want to work out the gender of a name in here. So again, we've defined the user as input.item.json, but then what we're going to do is actually use a helper function to create a HTTP request. So inside this code node, we can grab external data and make a request. So what we've defined is a URL here for a site called genderize.io. I'll go to genderize.io, very simple site, just basically says check the name of a gender, and they have the API docs in here. And all we're going to do is basically send a name and get back a response, which is a predicted gender of that name. So we've defined the URL endpoint we're going to send here. And also as a query parameter, we are sending the name here, which is user.firstname. And all we're doing is effectively sending that first name there. Now this is slightly more complex, and this is JavaScript code, but n8n handles a lot for us. We're basically saying that you as a code node are going to wait for a response from the URL that we're going to fetch the data from. So we use this await operation because it's asynchronous, or it's going to happen and we're going to have to wait for the response. So it's not going to expect immediate response. It's basically going to tell it, wait until you've got this response before you move on to the next parts. And then we've got this special helpers function, where we just use this notation, this.helpers.http request. And this is just a powerful built-in function inside of n8n. And we're saying request it from the URL, which is this URL here. So we're sending the first name to that URL, and we're saying return the data in JSON, or we're sending the data in JSON. I'm not sure which. And then what we're saying is return the data, again merged as keep all the existing datas, pull the gender from the response. So this response.gender, so we know from the APR documentation that the response is going to contain a count, a name, a gender, and probability. So we could return any of those and add them to there. So if we wanted to add, let's say, count, which is the count of the number of that name, we could say gender, because that's the response, gender count, which is our key, and then we'd say response dot count, I believe it was count, and that now should return the full user details that we had before, but also a gender count, a gender probability, and a gender. We've got the count, the gender, and the gender probability that it is actually that gender as well. So very cool. You can actually send external requests from a code node. Extremely interesting. Lesson 3 is all about processing all items at once. So if you didn't want to process each individual item, you wanted to process them as a group, then instead of using the run once for each item, we run once for all items. So we're basically saying grab all of the names here and perform some manipulation on all of those items. So if we run this, we'll see the output. We're effectively performing some aggregate statistics on that information. We're saying, okay, total users is 4 and the average age is 31.75. So this code only runs once for all users. It gets all items from the previous node. So we use the $items terminology here. And this is just something you need to learn over time with practice of which information to use. I'm just showing you how powerful it can be to use these. And then what we're saying is actually we're going to define this metric, which is total age, and we're just going to perform an action on it. So this is a bit more complex, and this digs deeper into JavaScript code and terminology there, but we're basically saying that we want to perform an aggregation on all of the total ages inside this object. And I'm not going to dwell on the detail of this specific notation. This is something that Claude or Perplexity can help you actually write. You just need to understand exactly what you're trying to do with the data that you're receiving. And then we've got things like inbuilt functions like length, which says, okay, grab the user count. Well, sorry, the user count is basically equal to all users, which was all of our items, dot length. So the number of objects inside objects. And then we've got things like total age over user age. We're basically just defining metrics in here, and then we're telling it to return this object. So we again have got a JSON object containing total users, average age, and inside the average age, we're just formatting it to 2 decimal places using more JavaScript notation. So don't dwell too much on the details, but you can basically perform statistical manipulations inside these code nodes. And then the final lesson is all around creating binary files. So believe it or not, you can actually turn things into files using JavaScript code. So we're going to aggregate all the items and generate a CSV in this case using just the code node. So again, this is something that's really powerful that you won't use all too often, but it's great to know that this is a concept inside n8n. And we've got key concepts in here, which is effectively we're grabbing the information from previous steps. So we're using this notation inside, which I'll show you in a second. And then we've got, again, another helper function inside n8n. This .helpers.prepare binary data. So we know when we work with a file, it's binary data, but it converts raw data into a proper binary file. And then buffer is a standard way to handle binary data in JavaScript. So we're going to see all of those concepts in here. But what we're doing is effectively we're trying to turn that information that we had earlier inside the fetch node. So this first name, last name, etc. And we're going to run it once for all items. And we're going to convert that into a file, which is actually super awesome. So we're going to grab all users again. And the way we're going to do that is actually reference a previous node. So this is something you will see quite often in code nodes. We're going to need to know how to reference a previous node, and it's similar to when we use our JavaScript expressions of double notations, except we don't need the double bracket notation. We just need the dollar and then the name here, and then what we're doing is grabbing all of that data from there. So we've got a list of all users or the object there, and we're going to start to define what the CSV content will look like. So we've got the different headers in there. And then what we're saying is loop through each item inside the all objects array. And for each of those, grab the user, and then we're defining what that row would look like. So where we put here full name, age, gender, guess, etc., we're effectively using the notation that passes in dynamic data, and we're saying grab the full name, comma, the age, comma, the gender, and that's going to fit under each of these headers, which we're going to put in the file first. And then what we're doing is we're basically saying put it on a separate row. So it'd be the CSV content, which is the headers, and then plus equals just means that we're going to add the next line to the next visual line, and the way we do that is using this -n. So again, this might seem a little bit complex, but you can use Perplexity and Claude and GPT to actually define these, but being able to read them or understand certain concepts is really important. And that's the important thing here, is actually you can create CSV files from this. And then we're going to use this helper to create a binary file from that. So again, we've got the else function, which says wait until it's done. And then we're going to use this .helpers.prepare binary data, which is an inbuilt function inside n8n. And we're using this buffer function, which is a predefined way in JavaScript to handle data. And then what we're saying is actually the CSV content file on which we added these rows to with a new line is now basically a list of rows, which is the header row and then all of the data rows. So we've got that in effectively like a prepared way. Now we're going to say from that CSV content, turn that into a report that's called user report.csv. And then always we need to return the items. So we're going to return effectively a date here, so when the report was generated, a user count, but then we're going to return the binary file. So if we execute that, you will see this returns in the table, it's the report generated when and the user count here. But in the actual binary file, we've got a CSV here, which we can download, and we can open that up, and we can see inside there that we've effectively got the binary data that's been created inside that code node. So that is how to master the code node in multiple different ways, create files, manipulate aggregate level data, manipulate single data, and also reference previous nodes. Once you've mastered these concepts, you will honestly find everything so easy inside n8n, because from then on, it's just rinse and repeat. Thank you so much for watching. If you like the content, please give it a like and subscribe below.